Today we're going to be talking about lesson 14.3 on the surface area of cylinders. So when we think about a cylinder, we can think about a can of vegetables or a can of soup. It kind of helps us picture what a cylinder is. So a cylinder is made up of two circles, one on the top and one on the bottom, and one rectangular lateral face. So that rectangle, if we would cut one straight line down the label of the can, and we would stretch it out, it's going to make a rectangle. So we know that the area of a circle is pi r squared. That's how we find the area of the circle. Since we have two identical circles, we can use the formula 2 pi r squared to find the top and the bottom. Now, we know that to find a rectangle, we use the length times the width. When we stretch out this rectangle, we see that it's really the distance around the circle is the length. Well, the distance around the outside of the circle is the circumference, or pi times diameter. So we can take pi times diameter times the height to find the area of that rectangle. They've also used the formula here 2 pi rh. Well, keep in mind that 2r, 2 times the radius, is also the same as the diameter. So 2 pi r squared plus pi times diameter times height, so the circumference of the circle times the height, to find the surface area of a cylinder. So when we look here, to find the surface area of a cylinder, we want to round our answer to the nearest tenth for these. So we have a base, a top, and a side. So remember pi r squared for the two circular pieces and pi times diameter times height for the side or that lateral face of that rectangle. So the radius of this circle is 6. So 3.14 times 6 squared. And remember that 6 squared is like 6 times 6. And then for this bottom here, we have 3.14 times the diameter. Well, if halfway across is 6, then all the way across is 12. Times the height of the cylinder, which is 9. So once we multiply these, you should end up with 113.04 and 339.12. Now we're going to go ahead and add these. 4, 4, and 2 is 10. Then we are going to add a 1 here. 1 and 1 is 2. 3 and 3 is 6, plus 9 is 15. Carry a 1. 1, 2, 3, 6. 1, 2, 5. So we have 565.2 yards squared. So again, we're talking about area, so we're squaring our units. 565.2 yards squared. Now, set up the next one, base, top, sides, using our formulas of pi r squared and pi times diameter times the height of the cylinder. Go ahead and plug in your information and try to solve this one on your own. As you plug in your information here, you should see that you have 3.14 times 3 squared, and 3 squared is 9. So 3.14 times 9 is 28.26. We have two of those because the bottom and the top are the exact same. For the sides or the lateral face, we have 3.14 times the diameter of 6 times the height of the cylinder, which is 18. 3.14 times 6 times 18 is 339.12. Again, we're going to go ahead and add these. So 6 and 6 is 12 and 2 is 14. 1 and 2 is 3 and 2 is 5 and 1 is 6. 8 and 8 is 16 plus 9 is 25. 2, 2, and 2 is 6 plus 3 is 9. and we bring down our 3. So we have 395.64 centimeters squared. Now, if we look here at the directions, it says to round our answer to the nearest tenths. So this is the 10th spot. So we use this 4 to tell us, does this 6 stay the same or does it increase? Well, the 4 tells the 6 to stay the same. So our final answer here should be 395.6 centimeters squared. Now, if we go ahead and take a look at the next one, it says if you looked in your book, in examples 2 and 3, the height of the can of peas is doubled. Does the amount of paper used on the label double? Does the value of the recycling double? And explain. So it says you earn 1 cent for recycling the can and assume the recycle value is proportional to the surface area. So the first thing I would recommend doing is finding the surface area of the original can and then finding the surface area of the new can if the height is doubled. So if the height is doubled, our new can would have a height of 4. So if we plug this in, so pi r squared, pi times diameter times height. The radius is 1 and 1 squared is 1. So 3.14 plus 3.14 plus the pi times the diameter, which is 2, times the height, which is 2. So that's 2 times 2 is 4. And 3.14 times 4 is 12.56. When we add these, we would end up with 18.84 inches squared. So this is the surface area of my original can. Now, if I double my height on my new can, I am going to find the new dimensions. So pi r squared, the radius is not changing. So my top and my bottom are going to stay the same. My pi diameter times the height, 3.14 times the diameter of 2 times 4. So 3.14 times 8, which is 25.12. Now when we add this, I have 32.4 inches squared. Now, for part A, it says, does the amount of paper used in the label double? So if we look, well, what part is covered in a label? The lateral side. So we know that this is a side and this is a side. Does that amount of paper double? Well, 12.56 times 2 is 25.12. So yes, the paper does double because we are only looking at the amount on the paper. So yes, the paper does double. Now for question B, it says, does the recycle value double? And explain. So for part B, I'm going to leave my answer down here, but we earned 1 cent for recycling 18.84 inches squared. So if it's considered proportional, that value is going to increase for the same size. But if we look, 18.84 times 2 is not 32.4. So since our total surface area does not double, our value will not double. So we can say that no, the value did not double since the surface area did not double or was not twice as much. And you could write a proportion to divide these to prove that if you were having trouble explaining it with reasoning.